Right. A quick thumbs up if you guys can hear me. Sorry, guys, I'm having some technical issues. A quick thumbs up if you guys can hear me. Thank you, guys. Okay, I'm going to continue. Now, then you've got 4 and 54, right? Now, once you have that, those are basically coordinates. So the number patterns, the number of terms represent your x coordinates, and your y values represent the value of the terms, which is exactly what a function is, right? So that's the relation with that, with the quadratic equation. So what you want to be able to do is that you need to understand what makes the quadratic pattern quadratic. And I know that we all know this, so I'm going to move a bit quick on this, is the fact that the second difference is constant, right? So you go, okay, first difference, 20. Remember, term after minus term before. And the reason I'm stressing it's possible for difference to be constant. Are you guys with me here? So make sure for constant to be negative. So make sure that you are comfortable with the fact that it's term after minus term before. In this case, 20 minus 9 is 11. And then you've got 35 minus 20, which is 15. And then you've got 54 minus 35, which is 19, right? And then you've got 15 minus 11, which is 4, and 19 minus 15, which is also 4. Thumbs up if you're still happy with that. Thank you. Now, if you go, how do we find the general term? Remember, the general term for a quadratic sequence is something that you're familiar with. It's just that it's a function of n, not a function of x, right? And we know that to find a, and I'm going to write this down here so that we are fine with that. To find a, we go to a. Let me just change color quickly here. We go 2a is equals to the second difference. 3a plus b is equal to the first term of the first difference. And a plus b plus c is equals to 9, the first term of the sequence. Now, this is important because it always remains the same, isn't it? And you've got to be able to, okay, I'm getting a lag, right? We've got to be able to find A, then find B, then find C. So you need A first so that you can go and find B, and then you can go and find C, right? Hence, that's how we find A, B, and C. Now, I also want to stress something here. Once you've got A, B, and C, and you have a general term, you need to understand that these formulas are not in the formula sheet. So you have to learn them. But of course, there is a foundation of where they come from, and that's where they come from, right? And I sort of did something like this with you already to say that if you go to the general term, right? I don't want to spend too much time on this. It's not examinable, but it's always good to know where things come from. There's the general term, right? Okay, I'm not sure you guys can see my screen because I can't see my screen. Okay, there's a big lag, guys. Just wait for my screen to appear.
We can see it.
Yeah, I can see the screen that you can see. You guys can see the screen with 2a, 3a plus b, a plus b plus c, right? And that's not the screen that I'm sharing. There's the screen that I'm sharing. Okay, there's a big lag, right? There's a big lag in Andres. Is there a way we can get around this?
I'll check on my side, then I'll let you know.
Okay. Sorry guys, there's a big lag and I'm only seeing it now, but it's fine. I'm gonna wait for the screen to show up. So on the screen, what you see now is how those formulas came about, isn't it? It said, oh, when n is equals to 1, right? When n is equals to 1, you've got a plus b plus c. Why? Because n squared, you've got bn, and when n is 1, this will be a plus b plus c from the general term formula. Thumbs up if you're happy with that a plus b plus c when n is 1. Thank you. And then when n is 2, likewise, back on the general term, you're going to get 4a plus 2b plus c, isn't it? And then when n is 3, you're going to get that. So when you now use algebra for T2 minus T1, you get 3a plus b. When you use algebra for T3 minus T2, you get 5a plus b. Then you go T2 of the first difference minus T1 of the first difference gives you the second difference. So 2a is equals to the second difference, 3a plus b is equals to the first term of the first difference, and a plus b plus c is equal to the first term of the sequence. Thumbs up if you are happy with where those formulas come from. Perfect. So the thing is, we don't need to go and learn the algebra of this, isn't it? What we want to learn is simply how to use them. So it's something that you've got to memorize. Thank you, guys. But as we memorize the formulas, it's always good to know where they come from. Right, now let's go back to this. Now, that means that you guys should be comfortable now to find the general term, isn't it? You're going to go 2a is equals to the second difference, which is 4. And our algebra, which we have been doing for the last 2 weeks, we know this is a linear equation because a is to the power of 1. So a one side, numbers one side, divide by 2. 4 divided by 2 is 2. Then 3a plus b is equals to 11. And then a is 2, so 3 times 2 plus b equals to 11. B is equals to 11. 3 times 2 is 6. Additive inverse minus 6. B is equals to 5. And then you've got, sorry guys, you've got A plus B plus C equals to 9, the first term of the sequence. A is 2, B is 5, plus C equals to 9. So C is going to be equal to 9 minus 7. C is going to be equal to 2, right? And therefore, the general term is going to be equal to an squared, which is going to be 2n squared plus 5n plus 2. Thumbs up if you're happy with how we find the general term of the quadratic sequence. Guys, if I can get more thumbs up, there's 33 of us in the lesson. We should be getting more thumbs up, please, so that we know that everyone is in this and we can understand what's going on. Thank you. That's better. Yeah. Right. Now, thank you, guys. Now, everyone seems to understand how we find the general term. So what we can now do is look at variation of this quadratic sequence. And guys, I really want us to be able to understand variation because it is what makes people not get a lot of marks on quadratic sequence. We've got to get the marks here. This is an easy topic for us. It's a level 1, level 2 cognitive level question. Every learner who wants to achieve 50% should be able to get it right. And I do believe that we are going to get it right. Now, if I give you another pattern, right? And I want us to do this together. If I give you 7, 16, 31, right? 52, and 79. That's quadratic, fair enough. But I want to say that in an exam, the question could be given as, hang on a bit. So the question can be given as 7x 31, right, is a quadratic sequence. So the sequence 7x and 31 is a quadratic sequence. And then the sequence of the first differences is 9 and y. The sequence of the first differences is 9 and y. So the question is, find the value of x and y, right? Find the value of x and y. So we already know what x is. What is x? 16, right? And to a certain degree, we know what y is going to be. 16 minus 7 is 9. 31 minus 16 is what? Is 15, right? But in this side of the question, on the right-hand side, we are given the question in terms of what? In terms of x and y. So we need to be able, and these guys, please make sure that you follow. We need to be able to solve questions where the sequence is given in terms of one unknown, right? So what you guys are going to do is you are simply going to say 7x 31. The difference here is 9. The difference here is y minus 9, right? And then we know that the only way you could get x is to say, the only way you could get 9 rather, is to say x minus 7 equals to 9. And then that would give you x is equals to 9 plus 7. And that would give you x equals to 16. Thumbs up if you're happy with how we find x equals to 16. Right? And then we know that 31 minus x, 31 minus x equals to y. But we already know what x is. So 31 minus x was 16 equals to y. And then that will be 15 equals to y. Thumbs up if you're happy with that. Thank you, guys. Now, let us now look at a deeper variation, all right? The one that we just did, there was only one unknown in the original sequence, and then one unknown in the linear sequence, right? What happens when there are two unknowns in the quadratic sequence, right? Remember, once you find the terms in the sequence, then you can be able to find the general term, which you guys are comfortable with, right? And again, I'm going to give it to you in another version. If I've got -5, -4, 4, 11. I'm going to have -4. Guys, it's very important to find this correctly calculated. -4 minus -5, which will give you 1. And then -1 rather, minus -4, which will give us 3. And then 4 minus -1 will give you 5. 11 minus 4 will give you 7. Then you've got 3 minus 1 is 2. 5 minus 3 is 2. And then 7 minus 5 is 2. Gonna wait for you for the screen to catch up. But I am pretty sure you guys are comfortable with what I'm doing here. Right, thumbs up if you're happy with that. Perfect. Now, guys, if I go -5 into x minus 1 into y and 11, how then do I find x and y? We already know the second term of the sequence is going to be -4, and the fourth term of the sequence is going to be 4. Now, the question is, how do we get to show x and y? Right, what is a quadratic sequence? Second difference is constant, right? So you guys are going to go x minus -5, right? Which is essentially x plus 5, right? And then -1 minus x. Sorry, guys. Y minus -1, which is y plus 1. And then you're also going to have 11 minus y. Thumbs up if you guys are happy with my first differences of the sequence. Perfect. Now, the second differences. I normally do them in the exam. I do them so that they are visible, but I don't want them to get my diagram messy. So I'm going to go -1 minus x minus, in brackets, x plus 5, right? That's T2 of the first difference minus T1 of the first difference, which is going to be -1 minus x minus 5, which is -2x minus 6. And that's my second difference. And then I'm going to have this one, y plus 1 minus into -1 minus x, y plus 1 plus 1 plus x, which is x plus y plus 2. Right? And then the last one is going to be y minus 11, or rather 11 minus y, minus, in brackets, y plus 1, 11 minus y, minus y minus 1, 10 minus 2y, 10 minus 2y, right? Now, what do we know? I have the second differences. What do we know about the second differences? They are equal. But I've got 3 different expressions of the second difference. Thumbs up if you're happy with that. I've got 3. They're the same, they're constant, but they are different expressions in terms of x and y, isn't it? And those expressions are the ones that are going to allow us to be able to find x and y. 2 unknowns, right? 2 unknowns, you're going to solve simultaneously. So what you're going to have to do is to say, we know that this and that are equal because they told us it's quadratic. So this is going to be x plus y plus 2, right? Then I am immediately going to say the only weird unknown here, the only unknown at least that's easier to solve for is y. So I'm going to have negative 2x minus 6 minus x minus 2. Additive inverse of that x and additive inverse of that positive 2 is equals to y. Negative 3x minus 8 equals to y. Thumbs up if you are happy with my algebra then. I'm just simply saying y is equal to negative 3x minus 8. Right? Now, the next thing we do know is that, and I'm going to do this with a different color so that you are able to follow. That difference and that difference are equal, right, as well, because there's still second differences. Okay, I do need out of the board here. Right. So we also know that x plus y plus 2 is equal to 10 minus 2y. Right? We also know that y is negative 3x minus 8. Right? So what we are going to do is where there's y, or at least isolate x, 10 minus 2y minus y, right? And then go x plus 2 equals to 10 minus 3y, just to make the equation easier. But you were ready to substitute minus y here, right? Then you're going to go, just waiting for the screen to catch up. You're going to go x plus 2 is equal to 10 minus 3. We know we have 2 equations, right? Equation 1, equation 2, right? Substitute equation 1 in equation 2. So it's simultaneous equation because you're looking for x and y. So where there is x, or rather where there's y, there's going to be negative 3x minus 8. And because you are fine with your simultaneous equation, you are going to be fine with your algebra here as well. X plus 2 is equals to 10 plus 9x plus 24, right? This is now a linear equation. The highest power of x is 1. So x is one side, numbers one side. So I've got 2 minus 10 minus 24 is equal to 9x minus x. Right? It's just me isolating the x's and the numbers. 2 minus 10 is minus 8. Minus 8 minus 24 is minus 32. 9x minus x is 8x. Then you're going to make x the subject of the formula, divide both sides by 8. Therefore, negative 32 divided by 8 is equal to negative 4. X is equal to negative 4. And once you get your x is equal to negative 4, you can then substitute back into the equation where y is the subject of the formula, which means you're going to have negative 3 into negative 4 minus 8 equals to 1. And then you're going to get negative 3 times negative 4 is positive 12. Positive 12 minus 8, therefore y equals to 4. Thumbs up if you are happy with that question. Right. I'm going to give you 2 questions to do. Right? I'm going to give you guys 2 questions to do. And once you get the first one, just type in your answers. X is this, Y is this, or whatever. All right? I'm going to give you the question. And the question is, the sequence 3, P, and 25 is a quadratic sequence. The first, the sequence of the first differences is 9 and Q. Question A, find P and Q. Find P and Q. That's 4 marks. I'm going to give you about 5 minutes to do that question. I'm going to give you 5 minutes to do that question. And once you have found the question, just type in your answers, guys. Type in your answers for me. Thumbs up if you can see the question, and thumbs up if you can hear me. I'm seeing P equals to 12, Q equals to 13, a lot of it. That's good. I'm seeing P equals to 14. Our algebra must have been off a bit there, but mostly we do seem to be getting it right. I have to say, I see P. I see P equals to 12. I see P is 14. There must be a mistake there. Q is 13. I see quite a few P is 12 and Q is 13. Okay, let's see. The sequence that is quadratic, right? The sequence that is quadratic is the sequence that is quadratic is 3, P, 25. The sequences of the first differences is 9 and Q. How do you find the 9? P minus 3 equals to 9. P is equal to 9 plus 3, which is 12. Thumbs up if you're happy with that. I see Precious is asking, what did I do wrong? Precious, can you see what you did wrong? Okay, I'm getting, people are fine. All right, that's fine. And then once you get the P is 12, then the Q becomes easy because Q was 25 minus P equals to Q. 25 minus 12 equals to Q, which means 13 equals to Q. Thumbs up if you're happy with that. And a lot of you got it right, which is very, very, very good. Okay. Now, I'm going to give you a second question to do. And I'm going to say to you guys, find the value of X and Y, right? For X 12, Y 19, for X 12, Y rather 28 forms a quadratic sequence. 4x 12 y 28 forms a quadratic sequence. Find the value of x and y and just type in the answers once you get them. And remember, guys, for now, it's not about finishing early. It's about being right. Once you know you can get the stuff right, you start working on your speed. So try and make sure you are doing this as careful as possible. Because if you make a mistake, it's going to be very tough to trace where the mistake is. You probably have to restart, and then you're going to be wasting even more time. So take your time before you type in your solution. And then once you get your X and Y, before you type it in, just sub it back in and see if you get a proper second difference. And then you can type your solution in. I'm seeing solutions here. I'm seeing X is 7, Y is 19. X is 7, Y is 19. Seeing more X is 7, Y is 19. And anyone else, if you're getting whatever you're getting, type in what you are getting. Thank you, Kamukelo. X is 9, Y is 15. Check if the second difference is constant, Kamukelo. Still waiting for everyone else. Kamukelo Ngwenya is not constant. So what does it tell you? A mistake. You still have time to go back and just check where you might have made a mistake. Start going through it again. Londi Wengu, I'm waiting for your solution. I'm getting more. X is 7, Y is 19. Helen, I'm going to unmute you. I'm going to ask you to unmute just now. What's up, Helen? Why are you lost? Helen? Hello, Helen? Okay, I can't hear you. Just type in. Maybe you might have connection issues. Londiwe, Brother Kamogelo, Ngwenya. Where are we now? Are you redoing it? Okay. Okay, Helen copied the wrong number. Okay, that's fine. I had made that mistake before. That's why it was not working out. Just work it out. Thank you. Okay. Kamu is also redoing it. And others, I'm still waiting. I'm not seeing enough answers here. Bongane, y is 19, x is 7. I'm happy with that. So I'm getting see where y is 19, x is 7. Can we send a manje some? All right. I'm waiting for more answers. Okay. We know that we've got to go and say x minus 4, 12 minus x, y minus 12, 28 minus y. And we know that the second difference is going to be 12 minus x minus into x minus 4, which is 12 minus x plus 4, which is 16 minus 2x. And then the other second difference, y minus 12 into 12 minus x, y minus 12 plus x, y plus x minus 24. And the other one, 28 minus y minus into y minus 12, 28 minus y plus 12, 40 minus 2y. And then you've got 16x minus 2x rather equals to y plus x minus 24, which will be 16 minus 2x minus x plus 24 equals to y. 16 plus 24 is 40 minus 3x equals to y. And then y plus x minus 24 equals to 40 minus 2y. Then we've got y, rather x minus 24 equals to 40 minus 2y minus y. X minus 24 equals to 40 minus 3y, and y is 40 minus 3x. X minus 24. I hope my algebra is correct. Kamu got it. Well done, Kamu. X minus 24 equals to 40 minus 120 plus 9x. And then I've got x minus 24 equals to minus 80 plus 9x. Then I've got minus 24 plus 80 equals to 9x minus x. Minus 24 plus 80 is minus 56, rather 56, positive 56 equals to 8x. Divide by 8, divide by 8. Yes, 7 equals to x. And then we already know that y was equal to 40 minus 3x. Y equals to 40 minus 3, and our x is 7. Y equals to 3 times 7 is 21. 40 minus 21 is 19. So x is 7, y is 19. So a lot of us got it right. I'm glad. And I'm glad, Cam, you also got it right as well. Guys, it does seem like we are getting the quadratic sequence. Now, we are still going to see it again when, okay, there's a big leg here. So I'm going to wait for everyone to just copy this down if they need to copy this down. So once you get a question where there's only one unknown, should become easier, right? And we'll see more questions like that next Monday when we look at the arithmetic sequence and the geometric sequence. It's important. And then remember, with the quadratic sequence, that the first difference is actually arithmetic, which means that there's a relationship between quadratic, linear, and the constant, and which we already know, but we need to see how that is going to be examined in the exam. So do a lot of quadratic sequences, because we do know we are not going to get a question without the quadratic sequence. It's about variation, remember? The more questions we see on quadratic, the better. Use your exam aids and do as many quadratic questions as possible. Today, we have come to the end of our lesson. Remember, with the quadratic sequence, know how to find the general term, which I think everyone does. Know how to deal with the quadratic sequence when it's given in terms of an unknown, both in the original quadratic sequence and the linear sequence. Know how to deal with the quadratic sequence if you're given a single unknown in the quadratic sequence. Know how to deal with the quadratic sequence, and this is the most complicated of all, when you are given two unknowns in the sequence. Then the third one, which is important, or rather the last one that is important, is that you need to be able to relate the quadratic pattern with the linear pattern. And we're going to see that on Monday when we introduce the linear pattern. And as we introduce the linear pattern and geometric pattern on Monday, we'll also be getting into sigma and sum, right? So this is important, right? And don't forget to join our WhatsApp channel. Andres has just sent the link now. That's where you're going to get all the important information, when are the classes going to be, reminders on classes, etc., etc. Right? Don't. This video will also be posted there and soon on the app. And then also, what is important is that, guys, if you've got any questions on the app, if you've got anything that you want me to treat in particular, send Andres a message on WhatsApp, on the WhatsApp, on the channel. Talk to Andres via email, and he will get that message to us. Again, thank you so much, Andres. He's just posted his numbers as well on WhatsApp, so that if you need any extra help, you can text him. He's a very busy guy, so he will get back to you, maybe not directly or immediately, but he will get back to you. Guys, thumbs up if you're fine today's lesson. And then I'll see you on Monday, right? And don't forget to rate us 5 stars on the Play Store. And I went back to Play Store the other day and I didn't see ratings. So please, everyone, go back to Play Store, rate us, right? We are going to, thank you guys. All right, I'm glad people got enjoyed the lesson. Ratings go a long way. That's Andres, guys. Please, it helps us, guys. Remember, it helps us with sponsors, so that we don't have to make you guys pay for these lessons. So make sure that you rate us and we can get good sponsors to continue these lessons. Thank you so much. Andres, anything you want to add?
I think you covered it, Samantha. So this recordings will be posted on the WhatsApp group and soon on the app. I'm just fixing something there. Then they'll start popping up there. And yeah, also follow us on Instagram and Facebook. That's where we post most of the important changes about app or upcoming features. So yeah, that's all from my side. Thank you so much, Manda, for yet another great lesson. Can't wait for Monday.
Thank you, Andres. All right, guys, that's it for today. I will see you on Monday.